Thank you very much. As I said, I'm Mark Hedges. I'm the coordinator of PERICLES, and I'm just going to start off by giving you just a sort of brief introduction and overview of what the project's about, and that'll be followed on by more detailed presentations on particular aspects. That's after Christine, anyway. So, well, it's PERICLES. It's got this rather long and contrived name, which is done partly to make the nice acronym, of course. It's it's a 4-year project in the when the former FP7 program has now been ended, and we've got Horizon 2020. But this is really one of the last tranches of FP7. It was in the digital preservation program within the broader ICT research program. And digital preservation, what's that mean? Well, we're addressing the challenge of long-term access to digital content in, as it says here, continually changing environments. It's a 4-year project. We're about a bit over halfway through. So we've done all sorts of useful stuff so far. Now it's all really starting to come together, I think. As a consortium of 11 partners altogether. Those are them. This is more about the partners. The coordinators, King's College London. We have 8 other technical partners, as I've called them, including universities like Borås here, but also research centres and also industrial partners, both large and small. So Xerox, big, a large one. Dotsoft being, well, not that small, but relatively small compared to Xerox maybe. And also, as well as technical partners, we've got 2, well, I've broadly called them use case partners. I mean, they're organisations that are responsible for various types of complex digital information, and they form sort of the use cases and the sort of test domains, if you like. There's Tate, which, in case you don't know, is a number of art galleries in Britain. They bring sort of expertise and needs from obviously the digital art, but also digital media. They produce digital media and archives, digital content in archives. BUSOC, which I'm afraid I can't remember, I can never remember what it stands for. As for Christian, I'll tell you later. I was thinking of it as Mission Control Belgium. Essentially, that, if I understand correctly, they monitor and control a lot of experiments and activities on the European Space Station, and they of course generate a lot of scientific data in the course of these experiments, very varied and hard, well, a challenge, let's say, to curate in the long term. What's the motivation for PERICLES originally? Well, we observed that digital content and metadata is generated and used across different phases in the life of digital information. It's traditional ways of doing digital preservation, often thought of in terms of an active life, where at the end of this active life you get a fixed and stable version that is then placed in an archive or repository of some sort and then preserved. This, we observed, was becoming a bit less relevant. And in contrast, we thought that approaches to preservation need to take into account that data, interrelated information is generated as a continuum in a continually changing environment, and this changing environment can lead to complete loss of access to information. It may just be completely unusable. A digital resource of some sort may lose functionality, so you may be able to access it, but it may not do everything that it used to do. And more subtly, you can have loss or change of meaning and thus reduce understanding of information as things change across time. You can still access the digital material in some sense, but maybe you understand it in a different way. So traditionally, a lot of work in digital preservation has looked at sort of technological developments, technological change. We consider that long-term sustainability requires us to look at change a bit more broadly than that. So as well as technological change, such as the obsolescence of data formats, obsolescence of software, we want to look at the semantics of digital assets, for example. The semantic drift, as it's sometimes called, that results from changes in language and meaning. Also changes within disciplines and society, which means that affect how the practices and attitudes of various stakeholders who may want to use or interact with this data in some way. Curators, artists, scientists, in the cases we've been looking at, or the broader public for that matter as well. And their basic sort of hypothesis, our sort of conceptual approach, if you like, was what's called preservation by design, providing sustainable access to data and information by ensuring that these digital resources remain usable through what we call a preservation by design approach. Now, what does this all mean? Well, future access to content requires not just information about the digital objects themselves to be preserved, which has been an approach that's been taken for some time, but it requires information about the whole environment to be in which that digital object was created and used. Requires that information to be captured and managed and interpreted as well. So not just information about the object, but information about the environment in which that object was being used. Thus, by preservation design, we mean that preservation is embedded into the design and architecture of data curation and records management or whatever from the start. It's not just an add-on that's bolted on at the end or as an afterthought, as in the sort of model where you get to the end of an object's life and it's stuck in a repository. But it's an integral part of the life of digital content throughout its life. So this semantic, this various forms of contextual information relating to the digital object is captured and analysed and represented within this bigger environment. Now, one way to implement preservation by design, which we've looked at, is through sheer curation, or something what's called sheer curation or curation at source as well. The idea behind this is that information about an object in its context, let's say its environment, there's information about that that's available when an object's created and used, which may not be available later. So typically, again, coming back to the model where an object is just deposited at the end of its life in a repository, at that point, a lot of this information about the environment in which the object was created and used would have been lost. That's what we mean by curation at source. It's done all the way through the object's life cycle. The other key concept here is the environment, or understanding that a digital object is part of a larger environment in which it interacts with other entities and is interrelated with other entities. This is sometimes what we refer to in PERICLES as the digital ecosystem. And these sort of concepts inform what we call our model-based approach to preservation, which is the other sort of key concept, I think, underlying the project. Just click onto that. As I said, in PERICLES, we use the term digital ecosystem to cover these digital objects and the sort of relationships between them that are needed to successfully reuse or, let's say, understand an object at a later point in time. So, okay, in one way you could think of the context as it could expand and expand. It could include the whole internet or all digital technologies that are anyway connected with an object. But of course, we don't do that. Rather, we just think in terms of the more limited set that have some impact on future reuse of an object. Nevertheless, to represent and process change even within this immediate environment of an object is very complicated. So the point of having a model-based approach, models are a sort of effective way to address complex issues by sort of distilling them, abstracting essential points from the environment of digital object. Those points are essential for a different purpose. So in a way, you get a more simplified view and just capture the essence for whatever you want to do. Makes the environment more clearly understood, and it produces a model that can be used. It can be used computationally then to, for example, to determine the effect of various changes in the environment on an object, a digital object, to carry out sort of what-if experiments, if you like, to see what would happen to the accessibility or usability of an object if certain things happen. These could be external things, external events, such as a piece of software no longer being available, or it could be deliberate changes that you want to make to your within your preservation environment. And these models can also be used to determine the actual effects of the effects of actual digital preservation activities. So if we do these sorts of preservation activities, what happens to our objects and our ecosystem, and thus to identify how one should go about preserving an object. In short, it can automate or semi-automate these processes of digital preservation, which becomes more and more important as the quantity of information that you need to preserve grows and grows. So, it's going to be a very superficial description of modelling, but we've been working on various sort of models. So there's a bit from more conceptual models for digital environments in which the objects are created and managed and used. So that's thinking of the sort of the conceptual digital ecosystem model. We've also been looking at more formal models, and together with sort of tools to support them that can be used to sort of describe and manage these digital environments. The objects, their relationships, dependencies on other objects, processes which an object can undergo. Also systems, ICT systems that are used to render an object or use an object, and also user communities, which are very important. Forget that things are preserved for user communities. It's not just preserved for their own sake. And these formal models underpin this preservation device design approach by supporting those involved in digital preservation to understand the dependencies and other relationships between digital material, and to allow the environments to be monitored and managed as they evolve. And we're going to look at a few specific modelling approaches in more detail in the talks that follow, so I won't go on about those, but I'll just mention them here. Now finally, to evaluate the research, I mean, we're doing all sorts of, it's a large project, a lot of research goes on, there's a lot of collaboration between people, but there's lots of little pockets of research. So how's this all put together? How's it all evaluated and sort of demonstrated in practice? Well, this is being done by developing a couple of test beds, one for each of these broad domains that we're looking at. And these test beds will enable the software tools that people have been developing, the models and the ideas more broadly to be evaluated in concrete situations, concrete scenarios that are meaningful to the to our stakeholder communities, our users from Tate and from BUSOC, and through them to, for example, the scientists that BUSOC represents. So these test beds provide a framework for actually implementing and validating specific use cases in concrete form. So we can run concrete tests, actual scenarios, preservation scenarios can be executed as computational processes. So we're actually, running programs, not just talking about it. Thus, our case study partners, Tate and BUSOC, provide scenarios that showcase real-life challenges that are able to evaluate the tools that we've developed, the models we've developed, and their usability and relevance for actual preservation practice. A couple of pictures, so you have a lot of words in those, just to illustrate the breadth of material we're looking at. Now, there are two very, very different domains, and the idea behind that was to try and produce something that was more work that was sort of more generic and could be broadly applicable. The left-hand side is a piece of software-based art. I can't really explain it, but I'm sure someone can if you're really interested. The bit on the right is the International Space Station, the solar experiment. Is that right? Which is the generating a lot of data relating to the sun. Obviously, if you can tell from its name. I didn't show you a picture of the actual data there because it wouldn't be very interesting. So I thought a picture of the spaceship would be far better illustration. Okay, so to sum up, we've done a lot in the last 2 years. I mean, these large projects, as I said, there's always a lot of people with sort of different interests, and part of the struggle of being coordinator is to try and bring them all together, to stop people drifting off in their own direction, which, when you're doing very interesting research, is very easy to do. But we're coming on very well, I think. There's still a lot to do in the remaining 2 years, especially the sort of integration of these various strands of research. we're very keen to sort of discuss our results with other people. As I said, we've got these two broad domains that we're addressing directly as part of the project, but in a, the sort of results we're producing, we want to be domain agnostic. They're supposed to be generally applicable. So we're very keen to speak to people from other backgrounds. And finally, yes, thank you all very much for coming to our workshop. And I'm happy to be here in Borås. I may even learn to pronounce it correctly by the end of the week. I've been practicing, but I still haven't quite got it. Thank you.